Alrighty, let's see what we got today. It's gonna be easy, I think. And I didn't actually. I had to cut the stream short yesterday, and I did eventually solve it, but it wasn't a very good solution. I might plate it with a better solution, restream it, or re-record it, but whatever. Alright, construct the minimum bitwise array, part 1. You're given an array nums consisting of n prime integers. You need to construct an array answer of length n such that at index I, for each index I, the bitwise or answer I plus 1. So one more than that previous value is equal to nums at I, i.e. answer I or answer I plus 1 equals nums at I. Bitwise or, okay. So if nums at I is like 10, then answer could be 9 or 10 or something like that. Answer I could be 9 or 10, or maybe answer I is 10 or 11. I don't think I actually said that correctly. Okay. Additionally, you must minimize each value of answer I in the resulting array. If it's not possible to find such a value, answer I that satisfies our condition, then set answer I equal to native. All right, let's just go ahead and look at the example here. 2, 3, 5, 7. So answer at 0 needs to be either 2 or 3. At I equals 0, there's no value such as there's no value for answer at 0. That satisfy answer at 0 or answer at 0 plus 1 equals 2. So answer at 0 equals 1. I'm not sure why it wouldn't be possible. Like, what if you just said answer at 0 equals 2? Okay, whatever. For I equals 1, the smallest answer 1 that satisfies answer at 1 or answer at 1 plus 1 equals 3 is 1 because 1 or 1 plus 1 is 2. The bitwise OR of 2 is 3. I think I see. now. It's not. This is bitwise OR. Yeah, whoops. It's not logical OR. It's bitwise OR. So if you do 1 or 2, 1 or 2 would be in binary 0, 1, or with 1, 0, which is going to equal 1, 1, which is like 3. And there's no two numbers that you are consecutive that you could do bitwise OR and get 2. Like if you do 0, 0, 1 doesn't work. 1, 2 gets you 3. And bitwise, you do bitwise OR with those values. 5 and binary is going to be 5 is going to be B1 4 0 1. So 4 2. So you could do maybe 4. No? Yeah, 4. So if you do binary of 1 0 0 or binary 1 0 1, it's going to give you 1 0 1. 4 there. And for 7, the smallest thing that could work is 3. Interesting. basically, it's not possible to do a bitwise OR with two values that with the nums value that is even, because if you do any two numbers that are one apart in binary form, you can get an odd. So evens just don't work. And for odds, it's kind of trivially possible to use one less than the number. So for instance, 3 you can use 2, 5 you can use 4, 7 you use 6, because one more than that number, that number plus the number one less than it is going to be like the only difference in the binary form is the ones digit. So all the other digits are going to be correct. All right, let's look at 7. 7 is going to be all ones. Okay. And then that means that the best or minimized value is going to be B of 3 and 4. Is that the only one? It might be It might be that. I'm trying to think of any other numbers that are odd, such that you can use something that is not one less than this, besides something that is maybe one less than power of 2. So it can use like 15. 15 is one less than power 2, so 13. Because 15 being one less than power 2 is going to be like B 8, 4, 2, 1, which is going to be B of like 0, 1, 1, 1, or B of 1, 0, 0. Like binary 7 forward with binary 8. So that's all you can work. Well, let's say it's 13. Can I use here? I have a guess that this is just, it requires this to be 12 binary with 13. So 13 binary form is going to be 8, 4, no 2 is 1. Yeah, I think it has to be. I think it has to be here just 12. Right? I think I'm wrong with it. What if it was something like binary? B of 12 or B of 13? It has to be that. What if I had a number in binary form that was like 1, a bunch of zeros, and let's say 2 ones? I think I can get away with, let's say it's 2 zeros. I think I can get away with saying B1, 0, 0, 0, 1, 0, 0, 1, 0. No, that is literally one less than that number. It's one less than that number. So let's say it's like 1, 1, 0, 0, 0. No, can't just do ones. 1, 0, 0, 0. Yeah, I think it is. It is the only kind of exception to using the odd number and the number one less than it is. If that odd number is 1 less than the power of 2, then you can use like kind of half the number plus 1. Okay, so answer array for every value in nums. If the value is even, which is divided by 2 as a remainder of 0, then answer is going to be -1 for that spot. Else, I guess the other main condition is if the value is 1 less than the power of 2. how do I check that quickly? Less than power 2 means that maybe a value plus 1 if I do log base 2 of this. I think it's going to be math log 2. Alright, math log 2. Log 2 accepts a single positive number as an argument, either integer or float, and returns the base 2 logarithm as a floating point number. As a floating point number. How do I check? We'll just do mod 1 equals 0. Parameter x must be greater than 0. Passing a negative number will be 0. Where's the value? We could also just do 2 to the power of this and check whether or not it's equal to 0. Kind of nasty. So this checks that it is actually 1 less than power of 2 because the exponent that you get when you do the logarithm is a whole number. So if that's the case, the answer appends. I guess you want to use half the number rounded down. So num value divided by 2. 7 divided by 2 is 3. Else answer appends value minus 1. I think that might be right. Oh, shucks. 11 is 9. Okay, guess I didn't do my logic correct. So 11 in binary is going to be 8, no 4s, 1, 2, 1, 1. The smallest thing here is 9. Oh, interesting. B1001 or B1010. Wow. Okay. I really did mess up my logic there. Okay. I was staring at something like this and I still couldn't get it. Okay, so I think the logic is the leftmost if there's consecutive left or the rightmost consecutive streak of ones, you can make that into, you can break that apart. Yeah, the rightmost streak of ones, you can break that into like some power of less than 2. So in this case it'd be 1, and then 1 more than that, which would be 2. So let's say you had a binary number that was like 1, 0, and this has 5 ones. You should be able to make this into, the 5 ones should be 4 ones. So this would be B1004 ones. Or, and then if you add 1 to those 4 ones, just this 1 extra bit becomes a 1, which corresponds to this one. Corresponds to the highest one in that streak of ones. So then you have something that fits. Okay. Rightmost streak of ones.
So simplified here, let's go ahead and just make this continue. So if it's not that, and then I just need to know how long the streak of ones on the right is. How long the streak of ones on the right is. How long is the streak of ones? So it's going to determine the leftmost or rightmost streak of 1 bits. So I think it's going to be, let's say streak starts with, I know the streak should be equal to 1 at the start of these because it's odd. I think I can do something with while value. So if I look at the last bit in value, it's going to be while. Actually, I need to copy this value. I want the original. Let's say current is equal to value. While current mod 2 current mod 2, the remainder of that divided by is 1, which means the streak on the leftmost bit is 1. Then I want to do streak plus equals 1, current minus equals, or current divided by. I can do a bitwise shift, or I can just do divide by 2. Divide equals by 2. Have a streak at some point. So it breaks when, let's say, streak is 1, and then the next bit is 0. So what happens if I do that streak? After the streak of ones on the right side of that binary number, there could be some number of zeros and then some number of other stuff, like other ones and zeros on the left. Like if there was binary 1 0 1 0 1 0, then followed by a streak of ones, then I need to somehow fix that. So like if I calculate this value here, if I calculate the streak of what the actual value is in the streak of ones, then I subtract that plus 1. Actually, I guess I subtract the power of 2. Subtract the power of 2. 11 goes down to 9, which is the difference of 2. And then 31 goes down to 15, which is 16. 7 goes down to 3, which is 4. So the streak that I'm dealing with, I think maybe 1 less than that streak as the exponent to the power of 2 that I deduct from the original value. So I think it's something like answer append the value minus the original value minus the streak 2 to the power of streak minus 1, something like that. I think that might be right. Okay, do I need all this jazz? wonder if this is faster than just doing a bitwise operation. Go ahead and ask. Is bitwise shift? I guess this should be shifting right faster than a division assignment, division by 2 assignment in Python. Difference is minimal and often not practical concerning one. Alright, sure. Cool. Alright, so this thing ends up being B1010010101 3 zeros and then like another 0 and 4 ones B or same plus 1. So here the summary is going to be the logic of the math can be summarized in the following. A, not possible to kind of deconstruct into kind of your consecutive binaries, consecutive numbers that bitwise or into an even number. It's just the ones bit and the consecutive or the ones bit, the consecutive or those when you or the consecutive numbers is going to be makes it odd. And then for odd numbers, which is the case, but it is actually doable. Consider the block, consider the rightmost block of ones. For example, let's say binary number 0, 0, 1, 0, 0 has rightmost block of 3 ones, like or even if you have 1, 0, 1, 0, 0. These ones can be broken kind of into into power of 2 and power of 2 minus 1. Where power of 2 is an actual number into some power of 2. So for example, B, let's say 1, 0, 1, 1, 1, can be broken up to be 1, 0. The power of 2 would be 1, 0, 0, and then the other one would be 1 less than that, which is 1 less than 4, which is B 1, 0, 0, 3. Okay. identify how many bits the leftmost, or sorry, the rightmost streak of ones consist of, and kind of correctly identify how that value compares to the original value. Let's see. In the end, the original value is always subtracted by a power of 2. Whose value corresponds to the number of bits, or number of bits minus 1 of the streak of rightmost ones. So in theory, let's say this is 1, 1, 2, 4. What value is this? 1 plus 2 is 3 plus 4 is 7. 7, this is 8, this is 16, so this is 23. And if you remove if you go from 23 to actually this value here, it's this single bit that you're kind of removing. So this bit is the third bit. So 2 to the power of 3 is going to be actually 2 to the power of 3 minus 1, so it's 4. So it ends up being 19 plus 20. 23 minus 4. 19 or 20. Where 19 is this, I want to say. 16 plus 1 plus 3. 1 plus 2 is 19. 20 is 16 plus 4. Anyways, yeah, and just have some logic for that. Use mod 2 to get the rightmost bit in your binary number. Mod 2 equals 1. That checks if the rightmost bit is 1. You divide the number by 2 to get rid of the rightmost bit, or you can do bitwise shift right by 1. You can also do that. Keep track of the streak of ones that you see, and then remove that value if you need to change the original value to whatever is minimum value. Complexity is O of n, where n is the number of values in the array. Each value means kind of O of b, where b is the number of bits. But since here bits is maximally like maybe 32, this might be considered just constant. Work considered constant. There's like O of n times b, where b is a constant. Fixed complexity can be O of 1, since no extra space is needed.